Okay, so let's look at these questions. Let's start with the very first one. Okay, so it says tomato plants usually have hairy stems. The hairless stems are present in the tomato plants that are homozygous recessive. Okay, so as soon as you see words like that, you have to circle them. Okay, so let's go ahead or underline homozygous recessive. Okay, so that means that it has two other recessive alleles. Now, one of the things you guys probably noticed when you started reading this question, you started thinking to yourself, hey, it didn't give me a letter. You can make up the letter. Nobody cares. So you have choices from A to Z. So I'm going to choose the letter H. That makes sense to me. So homozygous recessive, homo means same, and recessive means not expressed, so lowercase letters. Okay, so using the letter H, I know that the genotype for hairless stems is little h, little h. It goes on to say if the stem characteristics are determined by a single gene, what is the expected phenotypic ratio of crossing two tomato plants that are heterozygous for hairy stems? Okay, so if they're heterozygous, that means they have that dominant trait. Hetero means different. Okay, so big H, little h. Okay, and both plants are heterozygous. All right, cool. Let's go ahead and set that up. So number one, I know that they're both heterozygous, so big H, little h, crossed with big H, little h. Again, you could have chosen any letter in the alphabet, like nobody cares. Okay? And then I would put those in my Punnett square. Okay, law of segregation says that they separate, so big H here, little h here, big H here, little h there. Okay, so big H, big H, big H, little h, big H, little h here. Notice I'm consistent. I put the same letter. If it's heterozygote, I always put the big H first. Little h there. Okay? So you can do the genotype ratio. Have one big H right here. Two big H, little h. And then one little h, little h. Now, to answer the question, I know that the big H means that it has a hairy stem. All right, hairy stem. That's an H, doesn't look like it. And then two little h's would mean that it has a hairless stem. Okay? So the phenotype for this guy right here, big H, two big H's, hairy stem. These two guys right here will still have a hairy stem, even if they're a carrier for the hairless stem. It doesn't matter. Law of dominance says that if it has the dominant allele, it's going to express it. So these three right here are going to have hairy stems, and this guy right here is going to have a hairless stem. So I'm going to have three hairy stems and one hairless stem. Okay, and that was the answer to number 1. Okay, so these are 25 points each. Go ahead and give 25 points credit for that answer. Number 2 says Gregor Mendel crossed a true breeding tall plant, so a pure tall plant, homozygous, with a true breeding short plant. What are the possible phenotypes for the offspring? Well, it gives you the letters, so that's helpful. So a homozygous dominant cross with a homozygous recessive. That's the cross. I'm going to put it into the Punnett square. The law of segregation says they separate. Okay, so first offspring is big T, little t. Second, big T, little t. Third, big T, little t. And fourth, big T, little t. The genotype ratio, in each and every box, I've got big T, little t. So it's going to be 4 big T, little t. The phenotype ratio, what are they going to look like? Well, law of dominance says that if that dominant allele is there, then it's going to be expressed. So since there's a dominant allele in each box, each one of them is going to express the dominant trait, which is tall. So 4 tall. And that is the answer for number 2. 25 points for that one. All right, going on to number 3. Number 3. In Cocker Spaniels, the allele for a black coat color, big B, is dominant. And that's dominant over brown coat color. So that means that this is the recessive. That is the recessive. So whenever it's written that way, dominant over, this one's dominant, that one's recessive. Okay? If a brown Cocker Spaniel is crossed with a heterozygous black Cocker Spaniel. All right, let's think about that. So if the dog is brown, the only way to get that brown color is to have 2 little b's. So you already know what this dog's genotype is. And then you've got heterozygous black Cocker Spaniel. We know that hetero means different. And we know that black coat is dominant. So it's going to be big B, little b. You always want to figure out your genotypes before you move on. Now it asks me what genotype ratios can be expected. All right, so let's go ahead and set that up. So I've got the heterozygous dominant crossed with a homozygous recessive. Okay, I'm going to separate big B, little b, little b, little b. So the first offspring is big B, little b. The second, right here, is little b, little b. And big B, little b, little b, little b. Okay, so genotype ratio is what's in the boxes. So I've got 2 big B, little b. And then I've also got 2 little b, little b. Okay, phenotype ratio. What does that mean? Well, if there is a big B, that means that it is dominant and it's going to express the dominant. Doesn't matter if there's a little b right there. If that big B is there, it's going to express the dominant. And we know that the dominant, based on the question, says that it is black. So I've got 2 black Cocker Spaniels. And then this guy right here, these 2 right here are little b, little b. Well, there's no big B in sight, so the only thing that they could be is brown. And 2 brown. But the question asked me for the genotype ratio, so the answer is actually up here. Okay, so that is actually the answer. 25 points for that as well. All right, last one. All right, so chickens can have different types of feathers. Frizzled feathers curl toward a chicken's head. Assume that the feather type is determined by a single gene and that the allele for frizzled feathers is dominant. So, frizzled feathers is dominant over the allele for straight feathers. This one also doesn't give us a letter, so we can pick whatever letter we want. So I'm going to go with the letter F. Okay? It says to cross 2 chickens with straight feathers. Now let's go back. It says that the dominant is frizzled. So that means straight feathers is going to be recessive. And so the only way that you are going to get the straight feathers is if you are little f, little f. And so it says cross 2 chickens with straight feathers. So they both have to be little f, little f. So let's do that. So little f, cross with little f, little f. Okay, so I have a little f here, little f there, little f here, little f there. Okay, crossing them. Here's the first offspring, second, third, fourth. Now they're all the same, so the genotype ratio for each one of them is going to be the same. So 4, little f, and the phenotype ratio is all going to be the same too. And so what did little f mean? It meant straight feathers. So all 4 offspring are going to have straight feathers. All right, 25 points for that one. And I think, oh, we didn't finish. I didn't finish answering that question. So it says, what percentage of the offspring are expected to have frizzled feathers? Well, none of them, because they all have straight feathers. So we're going to go with 0. 0% frizzle feathers. And there you go.